what I'm going to be talking about is to some extent the opposite. It's the use of science for, in a way that really enters the world of wonder and awe, and is looking at some of the most interesting, long, puzzled questions of humankind. And remarkably, we live in a moment when some of those answers are coming. And with that, let me... You, right? You, slideshow here. Okay. This is the Crab Nebula. As normally, the presentation that I give is more about the science of astrobiology. What I'm going to try to do here, too, is to bring in some of the structures and spaces and whatever that's associated with it, and that are being found in nature and in the cosmos. And it is just kind of wild and crazy stuff. In any case, when you think about it, humans have always looked to the sky and imagined that there was life out there, and also that it was very, very important life. That's where gods were, that's where heaven tended to be, that's where in Islam jinns are, in the Chinese traditions the Jade Emperor is in the sky. In more recent times, that's where E.T. and Luke Skywalker and others are. I mean, so it's kind of, it's something that is, it seems, inherent in humans to hope for, to think that there is life beyond. Until very recently, it was basically belief and to some extent deduction, but it was largely belief. And that sometimes got us into trouble. This is in Rome. This is a statue of Giordano Bruno, who was kind of the patron saint of astrobiology. He was a Dominican priest, and then monk rather, and later became kind of a free thinker. Thought a lot about extrasolar planets or what might be out there, since we didn't really know about planets at that point. And also posited that there was life beyond Earth. And the Spanish Inquisition burned him at the stake. So this is just a way of saying that these are some of the issues that when there's this belief can get kind of hairy, and also that these are significant points that, that speak to something really important in human beings. So what we have now, though, is something that isn't belief, that isn't rational deduction. It is science. I mean, this is like, you know, real hardcore, some of the, to my mind, most exciting science on Earth is being done to determine whether or not, further along, whether or not there is life beyond Earth. I mean, and it is very consciously a policy. I was just speaking yesterday with a guy named Jim Green, who's the head of planetary science for NASA, and he said that we have now entered the age of astrobiology very consciously within NASA. They are hunting for life. And the irony of this is that it's kind of a stealth project, and some of that is intentional, because if you go to Congress and say, you know, we want some money to look for life beyond Earth, from history we know that Congress will say no. But if you do a lot of other cool things, then you can get the money to do it. This is kind of the opening, because this is the kind of science that they're finding. This was, this is not a photo, but rather a rendering of a sun with 6 orbiting planets that was found to, not like this, but was found through other kinds of calculations by the Kepler, NASA's Kepler mission, and it is, I think, 173 light years away. That's the kind of thing they're capable of doing now, is to find exoplanets at distances that are just mind-boggling. But let's first go here on Earth, because that's where kind of the story of modern-day astrobiology really begins. You can't see it too well on the left. This is a black smoker, which is a hydrothermal vent at the bottom of the ocean. This is kind of where extremophile work began. The vents spew out water that's somewhere around 600–700 degrees. And yet, to everyone's amazement, they found, not right in the middle, but kind of on the outer edges of it, where the temperatures were still extraordinarily high, they found microbial life and then even some larger life. This was maybe 20 years ago. But then that was quickly overwhelmed by other kinds of extreme life that was discovered. It turns out that Antarctica, which we all think of as just being like a very large, iceberg or ice cube, is really a biome that within these glaciers and within deep down, 1, 2, 3 miles into the ice, you're going to find microbial life in the ice everywhere. And what they determined is that when the when the water crystallizes, it forms kind of a little rivulet surrounding it, and it's semi-liquid, and that's where the salts go, and that's where other things that microbes could live on go, and wherever there's something that you can live on, then usually you can find microbial life. So we're getting to understand, well, wait a second, all of our sense of where life could be was wrong, or in any case was limited. Since you folks are involved with all kinds of interesting spaces and instruments, whatever, this is down at Lake Bonny, where this robot over the last 2 Antarctic summers was doing work under, I think it's about 6 feet of ice in a glacial pool, and it could go 1–2 miles out on its own, find all kinds of extraordinarily cool things, and it is what it is a prototype for what hopefully someday will be a mission to Europa, which you may know is a moon of Jupiter's, and it is covered in ice, and there is not a strong belief, but a knowledge that underneath that ice is a huge ocean. And in that ocean, we know there could well be life. As it turns out, in these glacial lakes in Antarctica, mind-boggling. Until 1995, there was no understanding that in Antarctica there was something called Lake Vostok. It was under a section of Antarctica that the Russians controlled, and it turns out to be the size of Lake Ontario. And it's about 2 or 3 miles down, and it is always water. It's always liquid. And the assumption is, and we will soon know that whether or not it's the case, that there's microbial life down there as well. On the drier side, we have the Atacama, which is in Chile, which is indeed the driest place on Earth. It sometimes doesn't rain in these areas for 10 years. And yet there's microbial life under some of the rocks, which again goes to show can't go anywhere without finding it. The Atacama is often used as an analog for Mars, and NASA does a lot of testing there. But to me, the coolest part is this. In the early mid-90s, this gentleman, who is a professor at Princeton, kind of on a hunch, based to some extent on some tentative research, said, I think if I went down a couple miles into the Earth, I would find microbial life there as well. Now, this went against all of the thinking at the time. He applied for a lot of grants from NSF and NASA and got absolutely nothing. Princeton didn't even give him money. So he got together his own money and went to South Africa, which has the deepest mines on Earth, the gold mines, and he started going down and trying to find things. He initially was looking in the rocks themselves, into the fractures, but then gradually came to understand that what he needed to do was to look into the water. And in the water that would sometimes come out through boreholes, and that was in the rock fractures and in little pools and ponds, whatever, he, over the years, found this microbe. which is called D. stolpidorus autoexpiator, probably the most famous microbe on Earth now, because it has been living down about 2 or 3 miles below the surface for somewhere between 4 and 40 million years without any connection to the surface of the Earth. Can you think about that for a second? You know, everything that we eat, that we think that, you know, that living things need, comes from the sun, and then gets, you know, through photosynthesis, gets changed and whatever else. They don't need this. They don't need this at all. Their energy source is not the sun, but rather the radioactive decay of some of the rocks around them, and then they break down hydrogen sulfide that's in the environment, and they get what they need to survive for that. And it is not just like South Africa where this is, and it wasn't just a few of these things that were found, but rather over a vast area. It is now understood that right below us, go 2, 3, 4 miles, you're going to find the same microbial life, and in fact, the mass of of life, of organic, of living biology below the surface of the Earth, and that's also below the oceans, is greater than what's above. So there's more living stuff below the ground than there is above. And this has great implications for astrobiology. Just to step back for a second, you know, what's the big deal about microbes? Well, you know, microbes, single-cell microbes were all there was on for like more than 3/4 of the Earth's life, you know, or the period that there was life on Earth. So, you know, birds and cats and us all came from 3 billion years plus of just microbial life. So if there is microbial life somewhere else, on Mars or Europa or some other distant planet, exoplanet that we discovered, that matters, since the flow of time is also vast here. You know, there probably have been planets going back 8, 10 billion years. Earth was created 4.5 billion years ago. So, you know, there could have been huge civilizations that lived and died well before there was even an Earth. In any case, microbes are a big deal. And because I used to be a foreign correspondent, I of course said, hey, if this guy went down into the mines of South Africa, so am I. I wasn't able to go with him per se, but I did go down with his team. It's too bad that the light is a little, you can't see too well, but you couldn't see very well down there either, because it's a mine and it's really dark. And you know, the light that you see is just from your miner's hat. As some of you being architects or students, or architects, in the back, it's kind of a little bit hard to make out, but we were taken to the end of a tunnel. I mean, you go down, we're what, 1.2 miles down, and then you hike for like an hour to the end of a tunnel. This is one where water had been seeping in. They put in all these huge, you know, phenomenal kinds of valves to try to staunch it. Didn't work. So they called the people who they knew were looking for extremophiles and said, look, we can blast this soon. You know, come and take your best shot. The guy on the right, you can barely see, his name is Gaetan Bourgani, and he is not a microbiologist, rather a nematodologist. He studies roundworms, which are ubiquitous on Earth. Not too many nematodologists, it's not a big field. However, this is what he found. This is mind-boggling. You know, he was doing the same stuff as Tullis Onstad. He would go down, he would filter the water coming out of the boreholes and out of the fractures, and he found a number, and quite a large number, of these very, very complex creatures that are living 1, 2, 3 miles down below the surface of the Earth. This was the first time that anything that complicated had been found at that kind of depth, and again begins to revolutionize our sense of like, what are the possibilities for life, not only here, but on Mars and a lot of other places. And the caliber of the research is such. This was published in Nature, which is, along with Science, one of the two big journals. Onstadt's work has also been published in that kind of. And this is just because I could. Here's a shot of me, and actually, you can't again tell too well here, but this space is remarkable. It kind of feels like you're in the middle of like someone's intestine, I mean, you're way, way deep. It's like 130 degrees. There's rocks all around you. There's some water down here because things have not gone real well. I took a whole bunch of pictures. They're all kind of fuzzy. This was the only one that wasn't too fuzzy because someone else took it. But the point I wanted to make was that despite the environment, it is now clear that if you could poke into the rock, you're going to find something living, and goes against all of your sense of what is possible in life. And in the rocks, you're talking about, because this is a very hot environment to begin with, and then there have been some volcanic activity 20 million years ago, and so it's still extra hot. You go in a meter or two, and it's 160, 170 degrees, and yet they're living things. All right, what does this have to do with astrobiology, or what additionally? Mars today, cold and dry. Everyone says, it's cold and dry, nothing there. We thought that there was before Viking, but Viking went up there and showed that it was kind of a desert, and so the sense that there was potentially life there kind of declined. It has subsequently come way back up, as I will describe. It is understood now, and this is an image put together by NASA, that if you go back 3.5, 4 billion years, that Mars was actually quite wet and quite warm. I mean, as in warmer than it is today out here. And so the conditions for there being life were much better. And this was during a time when the conditions for life on Earth were terrible. It was to some extent still molten, but beyond that, this was the period of the late heavy bombardment when huge size meteorites and small planets were hitting us all the time. And here's an interesting thought. No one has been able to prove this yet, so this is not science, but it's speculation. But we know that things were really bad until about 3.8 billion years ago, and then life, the earliest microbial life that has been detected is about 3.7 billion years ago. So it happened really fast in geological terms. And one of the theories came from Mars. We're Martians, man. Just face it. All right, this is what, 10, 15 years ago, Mars orbiters began seeing this kind of stuff. They thought that it was gullies of water, kind of reinforcing the notion that Mars had been wet and wild. This is just a phenomenal thing. This was taken a while ago, but just interpreted recently. This is a crater. You can't really see it here, but right in the line going this way, it descends. And it's facing the sun. And what they found was if you go back in the warm periods and look, and it wasn't just this place, but many, you see those black lines? That is probably surface water dripping. It's probably saline, so it could handle the cold, but it is still warm enough that you have surface water, which everyone says is like what you need for life, right? I mean, you need not only water that is deep somewhere, but you could potentially maybe even have some life on the surface. Adding to the, is there any way we can make this darker?
Can maybe kill some more of the lights.
Yeah.
Adding to the story here is that over the last couple of years, there's been some phenomenal, research done that show that methane, when we saw the image earlier of the cow collecting the methane. Most methane on Earth comes from biological sources. Something like 90% of methane comes that way. On Mars, there had just been trace methane that had been discovered over the years, but then some researchers went very intensely into a couple of areas. And what they found is that there were hotspots where a large amount of methane was being released, and it was happening every year, or every Martian year, at around the same time when it would warm up there and potentially the ice on the surface would melt, and so it would be released. So what you're having is not only water potentially, on the surface, but methane, which may have been biologically produced, may not have been, but may have been, burping out at the same places, same times. Does that mean, it could have been that there was past life, it could have again been geological, but it could also be that Mars was once a decent place to live. The atmosphere got, basically went away, the electromagnetic field disappeared. It got to be a very difficult place to live. So what organisms did was they went deep, like what we found here. And perhaps these are methanogens, which are a kind of microbe, bacteria, and they're releasing methane, which then pops up. This is your tax dollars at work. This is the rover Curiosity. It's going to blast off in a month or so, obviously in a capsule, and it's going to Mars. It is by far the most important, most sophisticated mission ever to Mars. If it lands correctly and doesn't explode, then we will start getting a lot more information about whether or not there are the signatures of life there, or even possibly life. It's not officially a life detection mission, because to do that they would have to bake the whole thing at a very high level, in which case all the instruments would be destroyed. They have to bake it for planetary protection purposes. But it does have the capability of telling us some things that would come very close to saying, yes, there was life there. All right, step back. It turns out, and this is again research that's been largely done over the last 15, 20 years, that everything that you need for life is out there in space. The complex hydrocarbons, these are polyaromatic hydrocarbons, are ubiquitous. Water is out there, oxygen is out there, hydrogen is out there, sulfur is out there. Everything that you need for life is out there in vast quantities. We know this because they've been able to do it through spectrographs, but also meteorites bring stuff to Earth, and they bring incredibly cool things. This is a Murchison meteorite. This is on display down in Washington at the Museum of Natural History. It's the most studied meteorite probably in history. It's a carbon-based meteorite, and it has in it, they have found, a wide range, up to 80 or 90 amino acids. Now, amino acids are not life, but they're building blocks of life. They're things that you need to make proteins, which then make life. What are they doing out there? And they've also found nucleobases, which are similar in the sense that they're not life, but they're building blocks for the genetic code. And again, why is it in Murchison? And Murchison, the question of contamination is always an issue. Did it land, and then what you're finding is what it landed in. But some of the amino acids there don't exist on Earth. So, it looks like this is, a lot of the stuff that's being found there really is extraterrestrial, and it is the building blocks of life. Who knew, but in fact, cosmic dust is falling on us all the time, especially today when it's snowing. And the amount that is coming now is a fraction of what it used to be back in those bad old days of the heavy bombardment. And so the take-home message here is that the building blocks of life probably were delivered from afar. The import of that, as I see it, is not only that it's fascinating for trying to understand how life began here, but also, man, there's zillions of other planets out there. The same thing can be happening there. The same dust is landing there with all those amino acids and nucleobases and complex hydrocarbons. Which is why exoplanets change everything. Until 1995, science and astronomers had speculated, for a long time that there had to be planets surrounding other stars. But they didn't have the technology, they didn't have the knowledge to determine that. Starting in 1995, there was a breakthrough, and then now they're up to more than 600 confirmed exoplanets, and another 1,000 that are on the registry to be confirmed. And the assumption is, not the assumption, the knowledge is now that exoplanets are everywhere, that there are billions of them. Not only are there billions of them, but this was something done by Jeff Marcy, who's one of the top people, planet hunters in the field. Based on what we know so far, that's largely the big planets, super Jupiters, bigger than Jupiter, planets bigger than Jupiter, and whatever. But we're getting, the astronomers are getting better and better at detecting smaller planets. And the more they can do that, what they're finding is that there are vastly more small planets than large planets. Now this is really good for astrobiology and thinking about habitability, because the big planets, nothing's going to live on them. I mean, they're just huge gas giants, and they're, some of them are verging on being stars. But when you get the little ones, then they get to be terrestrial, and they get to be rocks, and then things can land on them, and before you know it, you have cats. And this happens in what is now understood to be the habitable zone. On the left is the size of the star and the power of it, and then on the right is the distance, and you'll see that the habitable zone is kind of that area where water can be liquid. That's what you're looking for. We don't know that for sure that's the only environment in which life could be, but water is the best solvent there is, and so it makes sense. So that, and there have been claims in the last year to have found habitable zone planets. They're contested to one extent or another, but it is accepted as consensus knowledge or consensus opinion in the community that habitable zone planets are also ubiquitous, that there are billions of them out there. Interesting too, this just talks about the planets, but in our solar system, some of the best possibilities for where you're going to find life are actually moons of Jupiter and Saturn, especially Jupiter with Europa, but Saturn also with Enceladus and Titan. And there, what has been understood is that the power source is not coming from the sun, but rather from the tidal pull of between the big planet and the small planet, and so and radioactive decay also. So there is a lot of heat that's generated in some of those moons. And here's another extraordinarily cool thing. What astronomers can now do using spectrometry is to look at very, very distant stars and planets, and we're talking about 150 or 1,000 light years away, and they could detect what's in the atmosphere to some extent. It's a beginning science, but it is definitely something that is happening. And here's the clincher: oxygen and ozone exist on Earth in large amounts only because there's life. Oxygen binds very quickly with other elements, so that if there isn't a constant resupply of oxygen and then of ozone, then you're not going to find it in the atmosphere. So if they could find a planet that has a very high concentration of oxygen, then you can say, with a certainty of about 95% that there's life there, because otherwise there wouldn't be oxygen. once again, stepping back, we have a lot of stars in the universe. When I began working on the book about 4 years ago, instead of a 3 at the beginning, there was a 2. So every year there's they consider there a lot more, and the 2 doesn't mean it's just a little bit more. That means it's like a lot more. It put this into the same knowledge base as the fact that there are that the elements are all out there, and the planets, and that many of those stars, perhaps most of those stars, have planets surrounding them, and you could begin to see that there's a canvas out there that is kind of primed for life. How do people know this? And these are some of the images that I thought some of you who were particularly in architecture would find interesting. I had the good fortune to go down to Chile, where the European Southern Observatory is, and these are just unbelievable, very large, very powerful telescopes. And they're in the middle of this desert, and you can see, the sky in ways that are just impossible here. And this is why they come there. Because there's nothing else around. There's no light. There's no clouds. It is, as I mentioned earlier, probably the driest place on Earth. And as a potential architect, some of you see right in the middle, you see a little bit of a dome. Well, I have been driven in on the right through miles and miles of just nothing. I mean, you get excited when you see a boulder. And then we went over this little hill and came to this area where there were a couple buildings. But there was nobody out. It looked like there had been a neutron bomb, that went down. It was like scary. There was no one around. But the guide said, okay, well, we're going to go into that dome thing. And I was thinking, all right, well, that's like where they store salt, right? I mean, that's what it looked like. It was one of those places along the highway where they salt, where that happens. But I said, okay, fine. We walk down there and walk down a ramp, go through 2 doors, and what do you find? Boom. A rainforest. This was built by the Europeans who created the telescopes as a place for people to live, so that they wouldn't go crazy. It turns out people are not out on the surface because the ultraviolet light can be too bad, it could be too strong, and it could harm you. So people go in here and they spend their days. Actually, they sleep during their days because they're up all night. But it was just such a fascinating kind of view of how they had to organize in order to do their work, and probably similar kind of organization will have to occur in order to someday live on other planets. Okay, what else is happening? Well, this is a rendering, since there obviously is no camera out there taking pictures, but the Kepler has been out for about a year and a half. It's again revolutionizing the field of exoplanets. It's taking pictures of planets that what they're trying to find are ones that are transiting in front of their star, but very far away. And they have found approximately 1,000 of them, and the assumption is now, again, billions more. Given the Tea Party and other things and our debt, the days of the Kepler mission are probably gone for a while. People are starting to come up with more of the Rube Goldberg-y kind of things, but this is for real. These are little CubeSats. They're little teeny tiny things. They're like this big. One of the pioneers in the field has this idea of sending out like a whole armada of them. Each one would be designed to focus on one particular star, and then they would get a lot of information about transits just through that, and it would be very cheap. It could just kind of hitch a ride. Okay, just to review this a little bit, the logic of extraterrestrial life is far more tenacious than anyone ever imagined, 10, 15 years ago. Many billions of exoplanets like to exist, habitable zones everywhere, the molecules and compounds needed for life are out there. If life started once, why wouldn't it again? And then here's the other cool thing. If there is a discovery of a form of life on Mars that is different than what, the basic DNA structure that all living things on Earth have, then you have this fascinating situation where one kind of chunk change solar system, ours, ends up having two forms of life. At that point, you have to say life is ubiquitous throughout the cosmos, because the chances of that happening are just too small. Do I still have a little bit of time?
Yeah, I'm just worried about the train. It's about 3:40, so we should be.
If you're okay, I'm okay.
Yeah, let's do just a few more minutes.
Yeah. Okay. What life are we looking for? This we're not going to find. These are called snotties. They're gnats of microbes. Maybe we'll find that someday. This is a beautiful nematode. Who knows? This was a cool image that came from NASA. What they're trying to say here is that photosynthesis, as we understand it, not bad. Creates green plants, but if you have two suns, it keeps on trying to hello plants. What everyone obviously wants to know is there intelligent life out there? And the answer is, did you start doing this faster? Is that we don't know. This was all science that I told you before. The world of extraterrestrial stuff is like not science at all. And it gets very complicated because the nearest star is 4.2 light years away, which, absent the ability to go at warp speed, means that we will never get there. So what we're left with is stuff like SETI, where you're trying to listen for signals sent out by extraterrestrial civilizations. They've been doing it for 50 years, haven't heard anything. Some people say that that means that it's, it's ridiculous. They also now have optical SETI, which looks for laser beams. The people who run SETI say, they make this parallel. What we've looked at is equivalent to 1 cup of water in an ocean. So to say that we haven't found anything is, it's just not meaningful at this point. I spent some time in Japan also. This SETI in particular is something that is kind of a global phenomenon now. This gentleman did the first all-Japan SETI observation. He also helped organize, along with American SETI, the first global SETI observation. So even though it's not, to think that there is intelligent life out there isn't science, but they're using very sophisticated science to try to find it. And this is the cover of my book. I thoughtfully brought 6 copies in case anyone's interested. And if you're interested in a Japanese version, it was just translated, and I can get you one poster. Thank you.
Cool, thanks, Marc.
Sure.
Yeah, in the interest of time, we should get Simona, if you want to come up, we can start setting you up for the next presentation. I do have one quick question for you, which is about the idea of the shadow biosphere, and that even here on Earth there might be effectively non-terrestrial organisms, or organisms that are organized so differently that they don't correspond to what we consider life. I don't know if you can talk about that briefly.
Sure. There was a paper that came out in Science about 3/4 of a year ago that talked about this. It was research from Mono Lake out in California, and what the researchers found was that there were organisms that appeared to have substituted arsenic for phosphorus. Everything that's alive on Earth has in it 6 elements: hydrogen, oxygen, nitrogen, sulfur, and one of them is phosphorus. So if there was a life form that didn't need phosphorus, but rather could use arsenic instead, then that raises the very, very challenging and interesting thought that there could be different strands of life. And when you think about it, we know that life can happen on Earth. It did. Why would it happen once? Why would there only be one form? You know, maybe there were a lot of other forms, and then, you know, what became us succeeded, but there could be other still existing but not very advanced forms or forms that had been knocked out. Now I should say that research was very kind of viciously attacked by critics, and it became kind of a cause célèbre to go after it. I personally think that there is something to it, and over time we'll find out more about that. But the logic behind it makes perfect sense. That if there was life here once, why did it happen? Because everything on Earth that's living has the same DNA structure. But why does that have to be the case? Why couldn't it be something different?
Well, unfortunately, I think we need to leave it at that just for time. But yeah, thanks again very much, Marc.
Okay.
And,